Hey guys, I hope you're having a good day and it's about to get better because you're graphing linear inequalities, okay? All right, the good news here is if you've been graphing lines, this is not going to be too tricky, okay? It's very similar. There's just three things we need to remember, and I'm going to tell you those three things right now, okay? This is different than just graphing a line in three ways. We need to recognize if it's going to be a solid or dotted line. We need to finish with shading, and we also need to notice if we multiply or divide by a negative, we are going to flip our inequality sign. Okay, if you're like, what is she talking about? We're going to do it right now. Okay, so first thing I want to do is the easiest way to graph a line is in slope-intercept form. Now, slope-intercept form is when y is by itself. So right now, all I'm trying to do is get this y by itself. Okay, so first thing I'm going to do, add 9x to both sides. Okay. I'm going to simplify this down. So I have negative 3y is less than, I like to write the x first. So I'm going to put 9x plus 3. Okay, y is almost alone, but it's still being multiplied by a negative 3. So to get rid of that, I'm going to divide by a negative 3 on both sides. Okay, now this is when the alarm bells go off. Okay, we divided by a negative. So personally, when this happens to me, when I divide by a negative or multiply a negative and I'm doing inequalities, I like to circle my sign to remind me. Okay, like, oh, I divided by a negative. I got to remember that. I circle my sign. And then I also like to draw this little swirly arrow thing. I don't really know why. It's not an official math symbol, but there you go. Okay, so I'm going to simplify this down, and that little red circle and arrow are helping remind me to flip the sign. Okay, so these cancel, right? And I'm left with y. This is reminding me, oh, I divided by a negative, so I got to flip this guy. So it's less than or equal to. Now I'm going to change it to greater than or equal to. Okay? If you're like, there is no way that's legit, she's making it up, I am not. I will link a video in the corner for you where I explain why this is a thing. Okay? All right, we're just continuing to simplify. So I've got 9x divided by a negative 3. A positive divided by a negative gives me a negative, so I'm going to be left with negative 3x. And then I've got a positive 3 divided by a negative 3, which gives me a negative 1. Okay, look, y is by itself. Okay, so I'm going to circle this guy, or square him, I guess. This is now in slope-intercept form, so I'm going to graph it. Okay, so for half a second, I'm going to pretend it's an equal sign. We'll worry about it being an inequality in just a second, okay? So slope-intercept form, this is my slope, and this is my y-intercept. I'm assuming you're probably familiar with graphing these. If not, I'll link a video on how to graph a line in the corner, okay? All right, so I start with my y-intercept. Here's my y-axis. My y-intercept is negative 1, so right there. Then my slope is negative 3, or we can think of it as negative 3 over 1. Right? So I'm going to go down 3, 1, 2, 3, right 1. Down 1, 2, 3 over 1. Okay. And I can also go up 3, left 1, right? So 1, 2, 3, left 1, up 1, 2, 3, left 1. Okay. Now here is where I do need to recognize that this is not an equal sign. It is an inequality. Okay. I need to decide if this is going to be a solid line or a dotted line. Okay. How do I know? If we have less than or greater than, it's going to be a dotted line. Okay, in an inequality, when it's less than or greater than, my line acts as a boundary, but I don't actually have answers along that line. Okay, when it's less than or equal to or greater than or equal to, it is a solid line. Okay, because the answers can lie along the line as well. Okay, so this one, we've got y is greater than or equal to, so it is going to be a solid line. Okay. So here we go. It's going to look a little something like that, right? Okay, last step is shading. Because this is an inequality, I have a lot of answers, okay? My answers are either all of the ordered pairs along this line and on this side, or all the ordered pairs along this line and on this side, okay? How do we know which side it is? Okay, we are going to pick a point, any point we want, as long as it's not along this line. Any point we want, we can pick and plug in. Okay, now we usually like to make things easy on ourselves, right? We don't want to make things harder than they need to be. So typically, if we can, we like to pick 0, 0 because zeros make plugging things in kind of easy, right? So the only time you can't use 0, 0 is if it is along this line. And I'll link a video for in the corner where we do an example like that, okay? But we can do it on this one because it is on this side of my line, okay? So we've got X and Y. I know they're the same, but I like to label them anyway, okay? We can plug it into this, our original one, or the one we converted. It doesn't matter. You'll end up with the same thing. I'm just going to use this one, okay? So I'm going to have Y, which we are plugging in 0, is greater than or equal to -3 times X, we're plugging in 0, minus 1, okay? I've got 0 is greater than or equal to -3 times 0 is just 0, minus 1. So I'm going to end up with 0 is greater than or equal to -1. This is where I stop and ask myself, is that true? Is 0 greater than or equal to -1? Yes, it is. That is true, right? So what does that mean? That means the side that contains the point I plugged in, which we plugged in 0, 0, is true. So that means all of the ordered pairs on this side, and remember, this line goes on forever. The shading goes on forever also in this direction, okay? All the answers over here will work for this ordered pair. Oh my gosh, for this inequality, okay? So hopefully this made sense. If you need to check out some other examples, I will link a playlist for you. But hopefully this made sense. Thanks, bye.